All right, in this lesson, we're going to go over how to simplify rational expressions. All right, so the way that we're going to be doing this is first, I want to go over kind of what a rational expression is. And if you take a look at these first three, A, B, and C, you can notice that they all are fractions. And we have two polynomials, one on the top, one on the bottom. And the first one, A, is very simple, right? It just has x in the denominator. So when we talk about the values for x that you could use to plug into something like this, you could plug in anything you want to x as long as it doesn't make the denominator become 0. So that's true for all three of these. So you'll see when we get to these examples and it says state the domain, we're going to have basically all real numbers except for anything that's going to make the denominator become 0. So for example, this first one would be the domain would be negative infinity to 0 and then 0 to infinity, because essentially you can plug in anything you want, you just can't plug in 0. Same thing with this one here. The domain is going to be negative infinity until, if you look at the denominator, what would make that 0 would be negative 7/3, and then from negative 7/3 to infinity. And the last one is a little bit tricky. You'll notice that this one is actually factored. And when you have factors, you can cross things out. You'll notice I didn't try to cross anything out in letter B or letter A. There's no factors. But this one has x plus 4 on the top and the bottom. So you could actually rewrite this as 3 over x minus 4. But the domain, even though you crossed it out, you still cannot use that value. So we have negative infinity to negative 4, negative 4 to positive 4, and then positive 4 to infinity. All right, we'll get more in details on that with some examples. All right, so let's do some together. You'll notice some of them I've already finished. I'm not going to do all of them. There's too many to do in a video, hopefully under 20 minutes. So that's my goal, is to go through lots of examples, but make it something that you actually will watch. Okay, so we're going to simplify this expression and then state the domain. So this is an expression, so you have one polynomial on top, one on the bottom. And this is just really an exercise in factoring. So when I factor the numerator, I'm going to have x, and I'm going to have x minus 7 and x minus 1, right? Because negative 7 times negative 1 gives you positive 7, and they also add to give you negative 8. Do the same thing for the bottom. I'm looking for factors of negative 3 that add to 2. So I'm going to use positive 3 and negative 1. All right, now once you do that, once you are fully factored, if you have any common factors in the numerator and the denominator, you can cross those out and make 1. So the simplified expression is x minus 7 over x plus 3. Please, please, please do not cross out the x's here. Right, these are factors, right? You can see that they come from factors, so they have to be, everything is the same or connected by multiplication for you to cross things out. All right, now for the domain, just like we did in those first couple examples, we're going to have negative infinity. And when you look at the denominator, you have to go back to before you cross things out. So negative infinity to negative 3, right? That would make this denominator 0. Then negative 3 to positive 1. That would be this one up here that we crossed out. And finally 1 to infinity. So essentially you can plug in any number you want into this expression, but you cannot plug in negative 3 or positive 1. Okay, let's do letter D. Same idea here. We're just going to factor. I do notice that the denominator is not written in standard form, so let's go ahead and rewrite that as negative 2x squared plus 8x. So I'm going to go ahead and factor the numerator. I need factors of 16 that add to negative 8. This is actually going to be a perfect square trinomial where we use negative 4 for both. And then in the denominator, I'm going to factor out negative 2x, and that leaves me with x minus 4. Let's confirm that that's right. Yes. Okay, perfect. Now, this one is good to do as an example. That's why I chose it, is because you have two instances of x minus 4 in the top and 1 in the bottom. That doesn't mean you get to cross out all of them. You just get to cross out 1 on top with 1 in the bottom. Okay, so just keep that in mind as you're simplifying. And then it's going to simplify to x minus 4 over negative 2x. So my domain is going to be negative infinity to 0, right? Looking at this factor here, then 0 to positive 4. Even though I crossed it out, I still need to mention that you can't use 4. And then 4 to infinity. Okay, now let's change it up just a little bit. All right, so now we're going to get into some operations. All right, so I'm going to do C first and then letter D. So with subtraction, like we did in those 10 minutes after we took our last test to make sure you guys remembered how to add, subtract, multiply, and divide fractions from middle school, all right, we need a common denominator. Now, if you look at these two denominators, they're both quadratics. One's a trinomial, one's a binomial. So I would first recommend factoring. All right, so I need factors of negative 15 to add to 2. So positive 5 and negative 3. And this one is the difference of two squares. So x minus 5 and x plus 5. All right, and when you choose your common denominator, right, your LCD, you need to choose it's kind of weird because you think least common denominator or lowest common denominator, there's going to be like not a lot of stuff. A lot of times, guys, it is everything, right? So the way that I think of this is, if I look at this first denominator, I know I need x plus 5 and x minus 3. If I look at the second denominator, I have an x plus 5 here, and it's already written, so I don't need to write that again, right? I already have it. But I do need to write the x minus 5, right? Because that's going to be my least common denominator. So what I'm going to do is whichever factors they don't have, I'm going to multiply the top and bottom by what they need so that we have a common denominator. So I'm going to rewrite it and with some space so you can kind of see the way that I do this. All right, so that first one needs x minus 5 to essentially become that denominator. So the denominator needs to be multiplied by x minus 5. But in order to not change the value of this fraction, I need to also multiply the top by that. Same thing on this other side, right? This one needs an x minus 3 in the bottom, right? So it can look like that common denominator. And so also the top is going to have the x minus 3. All right, so now I'm just going to go ahead and distribute to get 4x minus 20. Now it's up to you. Some students like to keep the subtraction, distribute the 6, and then to do the subtraction. I would highly encourage you just to distribute the negative with the 6. So I'm going to write this all over x minus 5, x plus 5, x minus 3. And then what I'm going to write is plus, but I'm going to take this negative and distribute it with the 6. So negative 6 times x is negative 6x, and negative 6 times negative 3 is positive 18. I would recommend that. It'll save you steps and turns it to addition, which is always simpler. Okay, so now that we have a common denominator, I am free to go ahead and write this as one of these denominators. And my numerator is going to be 4x plus negative 6x, which is negative 2x, and negative 20 plus 18, which is minus 2. Now, if you wanted to, you could factor out in the numerator that negative 2, which would leave you with x plus 1. You don't have to do that because the x plus 1 is not going to cross out with anything in the bottom, so you can just leave it like this. All right, so that is it for example C. Okay, let's do example D. Now, D is division. And when we did this with the very basic fractions, we reminded ourselves that to divide fractions, you're going to copy the first fraction, which I just did there, and then change it to multiplication, and then use the reciprocal of the second one. So 2z cubed plus 8z squared goes on top, and the new denominator here is 30z squared minus 6z. Now, if you remember those first ones we did, where we simplified just one rational expression, I told you guys it was just basically an exercise in factoring. This division or multiplication, which division, it just becomes multiplication, is the same thing, but you just have to do more factoring, right? So I'm just going to factor every single one of these pieces, and once everything is fully factored, I'll see if anything can cross out. I'm going to take a moment to factor this one to the side here. So 5z squared minus 16z plus 3. This one is going to be a little tricky because a is not 1. So a times c that adds to b. So 5 times 3 is 15. That add to negative 16. So I'm going to use negative 15 and negative 1. So expanding the middle to be minus 15z minus 1z plus 3. And then using my grouping, take out 5z which will be z minus 3 minus 1 times z minus 3. Yep, that works. So these factors will be 5z minus 1 and z minus 3. All right, so I'm going to use those for my numerator here, 5z minus 1 and z minus 3, all over. This one's a little bit simpler here. So I'm going to have z and z, so I need factors of negative 12 that add to 1. So I'm going to use positive 4 and minus 3. And then times, over here I'm going to factor out, looks like I can factor out 2z squared and be left with z plus 4. Yes, and then all over this one I'm going to factor out, I think 6z. Let's see, 5z minus 1, confirm. Yep, that looks good. And so we're ready to cross out anything that's on the top with anything that matches on the bottom. And it can be in either one of these rational expressions, right? Because we're multiplying, it doesn't matter. So for example, the 5z minus 1 is matching with this one, that can cross out. The z minus 3, that crosses out. The z plus 4, that crosses out. The 2/6 reduces to 1/3. And then we have z squared over z, that z crosses out and leaves me with just z to the first power. All right, so all that's said and done, it looks like all the factors crossed out. That's left with just z over 3. All right, so that whole thing just simplified to z over 3. Okay, let's keep going. All right, let's see what I'm doing next. I'm going to do g next. I'm almost done here. All right, so this one has 3 expressions that we're going to put together with addition and subtraction. So very similar to the one that we did a couple examples ago. I do see I can factor some of this. So I'm going to factor these denominators to x times x minus 7. That one obviously is still just x, but this one is 2 times x minus 7. So I think this is the hardest part, is getting that LCD. And again, I know it's weird because you think least or lowest common denominator, but really it's just kind of everything, right? So I know I'm going to have the x and the x minus 7 from that first one. I don't need to write another x, right, for this because there already is an x in there. And then this one, the last one, I have the x minus 7 written, but I don't have a 2 yet. So I am going to put a 2 in front there. Okay, so now I just need to, and I'll rewrite to give myself more space. Now I just need to multiply each of these by whatever they need so they can look like the same denominator for all of them. All right, so starting with the first one. The first one needs just the 2. So 2 on top and 2 on the bottom would allow that to look like that LCD. This one needs a little bit more. It needs the 2 and the x minus 7. And this last one here just needs the x. All right, so now I'm going to multiply my numerators to get 20x over my LCD, 2x times x minus 7, plus, all right, so this is going to be 9 times 2, which is 18, 18 times x, which is 18x, and then 18 times 7, oh, we can do this, 18 times 10 is 180, subtracting 54, so is that going to be 126? I think it is, but I'm going to go ahead and just use my calculator just to make sure I did this right. And I was right, yay, 126 all over, and then the LCD, okay? And then I'm going to write, now this is where I would distribute the negative with the x, so I'm going to write plus negative 20x over 2 times, oh, I forgot that x outside, I apologize. 2 times x minus 7. All right, so now we've got the common denominator. So I'm going to add all the stuff on top here that's our like terms. I do notice that the 20x here in the front and the negative 20x at the end, those are actually going to make 0. So I'm just going to write down 18x. Oh my goodness. Sorry about my 8s there. Try again. 18, there we go. Minus 126 all over 2x times x minus 7. And now what I realized is that after doing that multiplication is that I actually can factor this 126 out, or excuse me, the 18 out to get 18 times x minus 7 over 2x times x minus 7. And I can cross those out to leave me with just, and this 18 is going to cross out, which gives me 9 over x, which will be my simplified expression. All right, so that was actually a lot to just get 9 over x. Okay, all right, let's go ahead and do, I think, our last one. Yes, our last one for the homework. So here's our last one. Now, I'm going to show you two ways to do this in class. I'm going to show you on this video just one way, because this is a complex fraction. You'll notice we have fractions within a big fraction. So you can find videos on both of these ways, I'm sure, out there. I'm going to show you the second way, which is a little bit more efficient on how to do this, but I will show you kind of the little slower way, but both are fine. There's nothing wrong with them. The way I'm not going to show you would be to treat the numerator as its own separate thing and the denominator as its own separate thing, deal with that, and then kind of bring them back together to figure out what happens. But for this video, I'll show you the quick way, which is to find the LCD. So I've got m plus 1, for sure, that's in my first one. I've got m minus 1, and then I have this m down here that I'm going to put. So what I'm going to do is I'm going to take that LCD, and this is different than what we've done for all the other ones. So I know this is going to be a little tricky, but I'm going to rewrite the problem with a little space. And for all of these, I'm only going to multiply the numerator by everything. So that is different. We haven't done this yet. So every single one is going to multiply each numerator by everything. All right, and then over 1 over m also is going to be multiplied by everything. And then last but not least, we have the 1 over m plus 1 multiplied by everything. Now, the reason we're going to do this is you're going to see that when we do it this way without doing both the top and the bottom, is that it's going to cross out with that denominator. So this m plus 1 and this m plus 1 goes away, and so you're left with just m times m minus 1 on that numerator. Minus this one, the m minus 1's cross out, so I'm going to subtract m times m plus 1. I guess I should cross that out too. There we go. This one, the m's cross out, so you're left with m plus 1 times m minus 1, plus this last one, the m plus 1's cross out, so m times m minus 1. Okay? Now from here, I'm just going to do more algebra, distribute to get m squared minus m. I'm going to distribute the negative with that m, so minus m squared minus m over m squared. Those are the difference of two squares, essentially, right? Because that's going to be m squared minus 1 plus m squared minus m. Now let's see what happens in the top. In the top, m squared minus m is gone, so negative m and minus m is going to be negative 2m. And then in the bottom, the m squareds are still there, so 2m squared minus m minus 1. So this right here is going to be our simplified expression, okay? So again, I know it still feels like we did a lot of work, which we did, but this is actually much faster than the other way, which I'll show you in class. All right, so take a look at the homework. Don't forget to come see me if you have any questions. Good luck.